Welcome to watch this video about capability modeling and matchmaking. This video explains the results of the research conducted at Tampere University of Technology during the European Union funded project ReCaM. The aim of the capability matchmaking is to support rapid design and reconfiguration of production systems. Let's start by a short introduction to the ReCaM project in general and its targets. ReCaM was a Horizon 2020 research and innovation program funded project running between November 2015 and October 2018 and coordinated by Bosch. The project had 9 partners. These partners included manufacturing end users, technology providers, and research institutes and universities from different European countries. The project targeted to develop versatile and easily reconfigurable production systems that would allow economic production of small lot sizes and high number of different product variants, and to reduce the time and cost of product changeovers and system setups. To support these goals, ReCaM developed different techniques and systems to facilitate the design, reconfiguration and management phases of production systems. These included, for instance, an approach for capability-based matchmaking of product requirements against resource functionalities, auto-programming of mechatronic objects, and engineering methods for integrated reconfiguration and production planning. The ReCaM solutions were demonstrated in 1 laboratory and 2 real industrial environments. For more information about the project in general, please visit the project website recam-project.eu. This video will focus on the work conducted by the research group in Tampere University of Technology, Finland, namely the resource capability management and matchmaking. First, we want to give you an overall idea of the capability matchmaking concept. After that, we will go into more details of each component which makes such matchmaking possible. In the end, we will demonstrate the concept with real industrial data. Let's start by explaining the overall objective of the capability matchmaking. The matchmaking scenario always starts with the need of producing a specific product. The system designer needs to figure out what kind of resources are needed to manufacture and assemble that product. Matchmaking supports both brownfield and greenfield design scenarios. In brownfield scenario, there is an existing production system which should be evaluated against the new product requirements and reconfigured to match with these requirements if needed. The system designer needs to analyze what is the capability of the existing system and can it produce the new product. Can all the needed process steps be completed and is there some changes needed to the existing system? Greenfield design scenario starts with an empty layout. There is no existing system. In greenfield scenario, the designer needs to find new resources from the resource catalogs which could produce the product. There are few aspects that the designer needs to evaluate during such process before making the final resource selection. Which resources can be combined together from their interface perspective? And what these resources can do together? Can these resources do the job at hand? The capability matchmaking approach aims to partly automate this search and evaluation process, which is traditionally done by the human designer, and let the designer now to concentrate on the final decision making regarding the resource selection. The capability matchmaking relies on different information models that are used to describe the resources and products in a formalized way. First of all, the matchmaking presumes that predefined modular resources exist. For each different resource, a resource description file is created and published by the resource provider. This description represents the basic characteristics, interfaces, and properties of the resource. It can contain links to documentation, CAD models, and to illustrative figures. One essential part of the resource description is the capability description of the resource. Central information model for the matchmaking is the capability model. It is a formal model for describing different capabilities, in other words, functionalities that the resources can have. When the resource is being described, the relevant capabilities are selected from the capability model and their parameters are detailed. The resource description files can then be saved to different catalogs, either global or local. From these catalogs, the potential end users, in this case capability matchmaking software, can then utilize these descriptions. Also, the product requirements are described using formal product information model. The product requirement description contains information about parts, how they are connected to assemblies, and what kind of processes and process parameters should be used. The product requirement description uses the same concepts that are involved in the capability model. Thus, there is a link between the resource capabilities and the process requirements of the product. The capability matchmaking is implemented as a service that the system designer may call through his desired planning system. When the designer wants to launch this service, he will have to give it certain inputs, which constitutes the matchmaking search space. This input includes description of the product for which a match will be looked for, and the description of the resources that should be taken into consideration during the matchmaking. This may be either a description of the existing system layout or a pool of resources selected from one or various resource catalogs. The capability matchmaking software will then process these inputs and provide the matchmaking result to the designer. The result indicates information about the resources and resource combinations matching for each process step of the product requirement. This information can then be further processed in the system designer's planning tool, where the desired resources are selected according to some company or situation-specific criteria. Now, when you have the general overview of the capability matchmaking, we can go into details of its various aspects. Let's start with the associated information models. The matchmaking relies on various distributed OWL ontology models used to describe the products and resources. In the bottom, there is the process taxonomy model, which models hierarchical categorization of different manufacturing processes. Next, we have the capability model, which models the generic capabilities that resources may have. The capability model imports the process taxonomy model, and the capabilities implement processes defined in the process taxonomy. On the next level, we have the resource model, which is used to describe resources. The resource model imports the capability model, and it models the resource-specific capabilities with resource-specific capability parameter values. The resource model also imports another ontology called resource interface model, which is used to give detailed description of the resource interfaces. On the other side, we have the product model, which is used to model the product characteristics and associated processing requirements. Now, let's elaborate these models in more details. The capability model is a formal ontology model which is used to model capabilities and their relations. Capability consists of concept name, such as drilling, milling, moving, and parameters which characterize the capabilities, such as payload, speed, torque, accuracy, and so on. The model consists of simple and combined capabilities, where the combined capabilities are combinations of simple capabilities. For instance, picking is a combined capability which requires as an input moving and some sort of grasping capability. The capability model forms a capability catalog, which is a pool of capabilities that can be assigned to resources to describe their functionality. The resource model ontology imports the capability model, and it is used to describe manufacturing resources and their capabilities. It can also be used to model systems composed of multiple resources. Device Blueprint class contains catalog information about resources, while the individual device class is used to represent the actual individual devices which may exist on the factory floor. The resources are assigned capabilities. And based on the relationships between simple and combined capabilities, it is possible to identify potential resource combinations that can have certain combined capability. These combinations can then be saved to the device combination class, and their combined capability can be saved through hash calculated capability object property. Resource interface model describes the resource interfaces in details. It is used during the matchmaking for checking the compatibility of the resources from interface perspective. In other words, it is utilized to assess if two resources can be connected physically together. It includes information about the interface definition, including identifier, name, category, gender, and purpose of the interface. Interface standards and its characteristics, and information about the standardization organization, and interface port implementation. The product model ontology is used to describe the product requirements for the capability matchmaking. It represents the parts and their basic characteristics, such as shape, dimensions, mass, and material, assemblies and subassemblies, and their contained parts, processes related to each part or subassembly, and sequence of the processes, and capability requirements related to these processes. Now, let's discuss quickly about what happens during the capability matchmaking. The capability matchmaking involves two aspects. First of all, the matchmaking must be able to generate new resource combinations for the different capability requirements. Secondly, the matchmaking needs to check if the capability of the resource matches with the requirements of the product. When new resource combinations are generated, there are two things to consider. What is the combined capability of the combined resources? And can the resources be combined from their interface perspective? Combined capability rules have been implemented to calculate the parameters of the combined capabilities based on the capabilities of the resources involved in the combination. Interface matchmaking rules are used to check the compatibility of the interfaces between the resources that are planned to be combined. Finally, when the resource combinations have been created and their combined capabilities have been calculated, these combined capabilities need to be compared to the characteristics and requirements of the product. For this purpose, capability matchmaking rules have been defined. They are implemented inside the matchmaking ontology, which imports both resource and product models. The rules have been implemented with SPIN rule language. SPIN is an abbreviation of SPARQL inferencing notation. Spin rules are attached to the classes of the ontology, and they extend the reasoning ability of pure OWL ontologies. The rule in the shown example is a combined capability rule, which is used to calculate the payload property of transporting capability, which in this case consists of moving and finger grasping capabilities. The capability matchmaking approach has been implemented into a working software, which I will describe next. Let's look first how the capability matchmaking system interacts with external software and databases. The matchmaking has been implemented as a web service which can be utilized by any external design and planning tool. The input sent from an external system to capability matchmaking is the matchmaking search space. It includes IDs of the product requirement description, layout, and/or the resource descriptions. Based on these given inputs, the matchmaking system will retrieve the product requirement description and the resource descriptions from the catalogs and read them into the matchmaking ontology. As a result, the matchmaking system will output the matchmaking result, which contains the IDs of the PRD steps and the IDs of the resources matching with each of these steps. Depending on the given inputs, some steps may not have any matching resources. Here you will see the overall software architecture of the matchmaking system. In the bottom, there is the data model layer, which contains the ontology models discussed earlier and other data models used during the matchmaking. Next, there is the data layer, representing the actual data used during the matchmaking. In the middle, there are the business and data access layers, which run and execute the matchmaking procedures. For instance, the Capability Query Library is a Java-based application developed to interact with the ontology models and to run the various rules needed during the matchmaking. It utilizes semantic web technologies such as Jena and OpenLet to perform the reasoning activities. The matchmaker executes the actual matchmaking procedure and produces the matchmaking results. The external software will interact with the capability matchmaking system through the matchmaking web service layer. It is implemented as RESTful web service, and it can be interacted through XML or JSON messages to send the inputs and to receive the outputs. Next, we will go through a simple case story which illustrates the use of the capability matchmaking approach in real industrial scenario. We will consider the greenfield and brownfield design scenarios side by side and indicate whenever there are some differences between these two scenarios. In the greenfield scenario, the design starts with an empty layout, and the whole system should be designed from the scratch. In the brownfield design scenario, there is already an existing system layout that has been used to produce some other product. In both scenarios, the story begins with a new product that should be assembled. In order to use the capability matchmaking, the product or process designer has to first create the product requirement description for the new product. That will be used as an input for the matchmaking. Here you see an example product requirement description and its content. In this illustration, it is modeled with the Protege ontology editor in the product model format. It contains the description of the parts and assemblies, the processes, and their related process capability requirements, including the parameters. The matchmaking obviously needs information about the resources. Thus, a prerequisite for the matchmaking to work is that the resource providers have generated the resource description files of their offerings and published them in some catalogs. Another input given by the designer for the matchmaking is the resource pool. It consists of the resources from the resource catalog which the system designer wants to include into the matchmaking search space. In the brownfield scenario, also the existing layout description is given as an input. The system layout consists of the description of the existing resource combinations on the current system. The matchmaking service doesn't have graphical user interface by its own, but it can be called by other software. The system designer or reconfiguration planner may use his preferred design or planning system, which then sends these matchmaking inputs to the matchmaking web service. In ReCaM project, these software were flexible system engineering platform used for greenfield design scenario and reconfiguration and production planning tool in brownfield design scenario. These software were developed by the Italian partners Enginesoft and Politecnico di Milano. Now, let's see what happens inside the capability matchmaking system when a request is sent. The matchmaking will check each process step one by one. In our example case, we'll use a process step which requires screwing capability. First, the matchmaking will create new resource combinations for the required capability at capability name level. While creating these combinations, it will simultaneously check that the interfaces of the resources match and the resources can be physically connected together. In this case, the toolbit doesn't fit to the screwdriver, and thus incompatible combination is filtered out. After that, the matchmaking will check that the capability parameters match with the parametric requirements of the product. In this example case, it will check that the screw type and screw size matches with the tool size and that the provided torque is within the range of the required torque. Unsuitable resources and resource combinations are again filtered out. In this case, the combination possibility 1 does not provide enough torque and it is eliminated from the result. Only the suitable resource combinations are left as suggestions in the matchmaking result. Here you'll see an example of the matchmaking result in HTML format. It shows the process steps, found matches for the process steps, and the resources which are included into these found matches. Furthermore, a rough estimation of the average processing time with the given resource is provided. The two proposed resource combination possibilities from the previous example are highlighted here. After the results are generated by the matchmaking software, these results are delivered back to the client that was requesting the matchmaking. The results contains each process step and the possible resources and resource combinations that can do the requested step. The matchmaking system doesn't provide ready system design. It is the task of the designer to select which of the suggested resources and resource combinations to use and how the tasks should be allocated into the workstations. In order to do the system design and reconfiguration decisions, the matchmaking results can be further analyzed with the designer's planning system. With the help of this system, the designer will make decisions on what resources should be used, how the existing system needs to be reconfigured, and how the new layout should look like. Once the new configuration is in place, the production of the new product can start. Finally, We want to emphasize that the matchmaking supports iterative approach in which the search space may be gradually enlarged during the design process. The process and inputs depend on the reconfiguration or design strategy the designer wants to apply. For instance, the matchmaking may start with only the current layout to see if the existing system as such could produce the new product. If that is not the case, the existing layout may be broken down to allow new arrangements of the resources. Next, the resource pool may be extended with other in-house resources existing in the company storage. Finally, the search may be extended to global resource catalogs from various resource providers. It is up to the designer what kind of strategy to apply. Thus, this sequence was just an example. We would like to conclude this video by shortly discussing the impact of the presented resource management and capability matchmaking approach. For the manufacturing companies and system integrators, the matchmaking can provide automatic means to search and find alternative resources and resource combinations for specific needs from different resource catalogs. This means that less manual effort from the designer is needed to find and evaluate different alternative solutions, and more alternative resources and configurations can be considered than earlier, as now the time-consuming search and filtering is performed by automatic means. This may also lead to innovative solutions that would not have been considered with the traditional manual design approach. Based on these advantages, the matchmaking approach can reduce the time needed for system design and reconfiguration planning, and thus enable more flexible and adaptive manufacturing of high-variety products. From the resource provider viewpoint, our approach provides a common format for describing the resource offerings. These resource descriptions can then be published through global resource catalogs. The common description format means that the different resources from different vendors can be easily compared, and also their integration to overall multi-vendor system gets easier. Through the global resource catalog, the company will get wide visibility for their offerings. Also, it is beneficial that the automatic matchmaking approaches, like the one described during this video, can automatically find these resources from the catalogs. All this is expected to improve and increase the business opportunities of the resource providers. We would like to thank you for watching this video about the capability management and matchmaking. The explained work was performed by Tampere University of Technology during the Horizon 2020 research project ReCaM. For more information about the project, please visit the project webpage. If you want to read more about our work, please check the links given in the description of this video. Free access to the information models is provided with Creative Commons license. Also, great amount of our publications are available as open access.